Why did the ground in Texas just move in a way that isn't supposed to happen there? Something buried 500 million years under cattle country just woke up, and even the scientists studying it right now are not fully sure why. Before we go further, hit that like button, hit subscribe, and send this to one person who still thinks Texas is too flat and too boring for anything strange to happen underground. You'll want them to see this too. Early Thursday morning, long before sunrise, a stretch of quiet ranch land in the Texas Panhandle jumped. A magnitude 5.1 earthquake tore through Roberts County, close to the Oklahoma border, in a part of the state where most people have never once worried about the ground shaking under their feet. This is wheat country, cattle country, the kind of flat, wide-open land where the biggest worry is usually a hailstorm or a tornado, not a fault line cracking open beneath the soil. When people hear Texas and earthquake in the same sentence, their mind jumps straight to one word: fracking. That reaction makes sense. It's the story most of us have heard for years. But here's the first thing you need to understand, and it's going to reshape how you see everything else in this story. A quake this size would be unusual, even if it had been triggered by human drilling. Most earthquakes linked to oil and gas activity are tiny, often too small for a person to even feel. For an induced quake to reach magnitude 5.1, it would need to hit an already weak, already stressed fault line almost perfectly. That's rare. And the deeper you look into this specific event, the less it looks like a simple case of drilling caused it. So what actually happened here? Let's lay out what nobody disputes. The quake struck at 5:21 in the morning. It was centered near the small town of Miami, Texas, not far from the Oklahoma state line. People felt it as far away as Oklahoma City and Tulsa, more than 200 miles from where it started. Later that same day, a second and much smaller earthquake struck hundreds of miles south in a completely different part of the state. Nobody was hurt in either event. No major damage was reported. On paper, it sounds almost quiet. A shake, a scare, then nothing. But underneath that calm surface is where this story turns genuinely strange. I went through report after report on this event, from major news outlets to seismology bulletins, and almost none of them agree on how rare this actually was. Some call it the strongest earthquake ever recorded in the Texas Panhandle. Others call it the strongest in more than 100 years. A few go even more specific, saying it's only the fourth earthquake of magnitude 4 or higher in that region since the year 1900. So which is it? How can experts disagree on basic facts about something that happened just hours earlier? That contradiction isn't a mistake. It's actually a clue. And by the end of this video, you'll understand exactly why the experts are talking past each other, what's really buried under that stretch of Texas, and why some geologists are quietly comparing it to one of the most violent earthquake sequences in American history, one that happened almost 1,000 miles away. Let's start with the ground itself. The epicenter sat in flat, sparsely populated ranchland, the kind of place with more cattle than people for miles in every direction. The quake was shallow, only a few miles below the surface. That shallow depth is exactly why the shaking traveled so far. It wasn't just felt nearby. Reports rolled in from Amarillo, from Lubbock, from southwestern Kansas, and even from the edge of the Dallas-Fort Worth metro area. Some residents said they felt shaking from a source nearly 250 miles away. People near the epicenter described being jolted out of bed by a deep, rolling sound like distant thunder, except this thunder came from beneath them instead of from the sky. For a region that already deals with real thunderstorms, tornadoes, and hail on a regular basis, that detail alone tells you how unfamiliar this felt to the people living through it. Within hours, hundreds of felt reports poured into the United States Geological Survey. Seismologists across 3 different states suddenly found themselves paying very close attention to a stretch of land that, on any normal day, almost nobody in their field thinks twice about. Let's slow down for a second and talk about what a magnitude 5.1 actually means in plain terms, because the number itself can be misleading if you don't have anything to compare it to. The magnitude scale is not a straight line. It's logarithmic, which means each whole number jump represents roughly 10 times more ground movement and about 30 times more energy released. So a magnitude 5 earthquake isn't just a little stronger than a magnitude 4. It's an entirely different category of event. A magnitude 3 might rattle a coffee cup on a shelf. A magnitude 5 can crack plaster, topple chimneys, and in older or poorly built structures, cause real structural damage. When you hear that this quake reached 5.1, you should picture something closer to a sudden, violent jolt than a gentle tremor. That's part of why it traveled so far and rattled so many people out of bed before sunrise. Here's something most people watching this don't know. The Texas Panhandle has actually been quietly shaking for more than a century. Seismic records for this exact area go back to 1907. Since then, researchers have documented roughly 20 separate earthquakes across that same general stretch of land. 3 of them, before this new one, crossed the magnitude 5 mark, happening in 1925, 1936, and 1948. A handful of smaller ones followed after that in 1951, 1974, and 1980. So this land has a history. It isn't some brand new phenomenon appearing out of nowhere. It's an old pattern, resurfacing again. So what exactly is sitting underneath that quiet stretch of Panhandle farmland? This is where the story becomes almost hard to believe. Deep beneath that soil lies a buried fault system tied to something geologists call the Amarillo-Wichita Uplift. It's the remains of an ancient rift, a place where the North American continent itself once tried to tear apart and simply never finished the job. This failed rift dates back to the early Cambrian period, roughly 500 million years ago. That's long before dinosaurs walked the earth, long before anything with a backbone had even crawled onto dry land. And it's still down there, quiet most of the time, but not gone. Think about what 500 million years actually looks like. If you compressed the entire history of Earth into a single 24-hour clock, human beings wouldn't even show up until the last few seconds before midnight. This rift formed back when the clock had barely ticked past noon. Continents were arranged in shapes we wouldn't recognize today. The very idea of Texas as a place on a map wouldn't exist, for hundreds of millions of years afterward. And yet the physical scar from that ancient attempted split never actually disappeared. Rock doesn't forget the way we do. A weakness carved into the crust that long ago can sit patiently for an almost unimaginable stretch of time. And then, under exactly the right amount of pressure, it can move again, just slightly, just enough to be felt hundreds of miles away, by people who have never once thought about what's underneath their own front yard. Is this ancient scar the reason the ground moved on Thursday? Don't answer that too quickly, because there are 4 separate explanations currently on the table, and even the scientists studying this event haven't settled on just one. Let's go back for a second to that disagreement about whether this was the strongest quake ever recorded in the region, or just the strongest in a century. The explanation turns out to be more interesting than the disagreement itself. An earlier Panhandle earthquake, estimated at magnitude 5.4 back in the 1930s, was never actually measured by a seismograph, because there wasn't one anywhere near that remote stretch of land at the time. Instead, scientists from that era pieced together the size of the quake by mapping where people reported feeling it, and were any cracked walls or damage turned up. In other words, they built that number from old letters and word of mouth, not from instrument readings. That estimate might genuinely be close to the truth, but it's a fundamentally different kind of number than one captured live by modern seismic instruments. So when different news outlets call Thursday's earthquake the strongest ever recorded, they usually mean the strongest ever measured directly by an instrument, not necessarily the strongest one to physically happen there in the full sweep of the region's history. Once you separate those two ideas, most of the confusion clears up. It's not that anyone is lying or getting the story wrong. It's more like comparing an old hand-drawn sketch to a modern photograph, and then arguing about which one is more accurate. That single distinction tells you something important. The full picture of Texas's earthquake history is a lot blurrier than this week's dramatic headlines make it sound. Now let's walk through the 4 competing explanations for why the ground moved. The first explanation is the one we've already been building toward. This ancient, failed rift essentially woke itself back up. This is currently the leading natural explanation among geologists. Tectonic stress slowly builds up across an entire continent over long stretches of time, and eventually that stress finds the weakest point available in the crust and releases there. In the Panhandle, that weak point happens to be this same old failed rift. Under this explanation, no human activity is required at all. It's simply geology doing what geology has always done, just operating on a timescale that makes an entire human life look like the blink of an eye. The second explanation is one almost nobody's talking about, even though it's genuinely fascinating. Old oil fields, dating back many decades. Several historical Panhandle earthquakes happened directly above major petroleum fields. The earthquakes in 1936, 1966, 1974, and 1980 were in areas that were actively being drilled at the time. Researchers who studied those older events suggested they might have been triggered by that historical production, but those same researchers were honest about a real limitation. The equipment available back then simply couldn't pin down the precise depth or location of those earlier quakes with much accuracy. So this remains a genuinely open question, not a settled conclusion. It's worth pausing on this one because it doesn't get nearly the attention it deserves. The Panhandle sits above one of the oldest continuously producing oil regions in the entire country. Wells have been pulling oil and gas out of that ground since long before most of the equipment used to study earthquakes even existed. Removing large volumes of fluid from underground can change the balance of pressure in the surrounding rock. Sometimes that is enough to nudge a fault that was already close to slipping. This isn't a fringe idea. It's a documented phenomenon in mining and drilling regions around the world. The trouble is that by the time modern seismologists gained the tools to study this properly, decades of that older production history had already happened. This history was recorded imperfectly or not recorded at all. So this explanation sits in an uncomfortable middle ground. Plausible, historically grounded, but almost impossible to prove or disprove with real confidence using data collected so long after the fact. The third explanation is the one most people jump to first, the moment they hear Texas and earthquake together. Modern wastewater injection tied to oil and gas drilling, commonly linked in the public mind with fracking. This is a real, well-documented phenomenon in parts of Oklahoma and West Texas. Researchers have clearly shown cases where pumping leftover drilling fluid deep underground measurably triggered earthquakes along nearby fault lines. But officials responding to this specific Panhandle event have been notably cautious. They are saying plainly that more data is needed before drawing any firm connection. A magnitude 5.1 is genuinely large for a quake caused mainly by fluid injection. And unlike the extensively studied cases further west, this event simply doesn't have that same weight of supporting evidence yet. To understand why scientists are hesitant here, it helps to know how wastewater injection actually works. When oil and gas come out of the ground, they bring up huge amounts of salty, mineral-heavy water along with them. That water isn't something you can just pour out on the surface. It gets pumped back down into deep disposal wells, often far below the layer that produced the oil in the first place. Over time, if enough of that fluid accumulates near an already stressed fault, it can act almost like a lubricant. Reducing the friction that was holding 2 blocks of rock in place is the mechanism behind most human-caused earthquakes in this part of the country. But for that mechanism to produce something as large as magnitude 5.1, you typically need a very specific combination of factors. A large fault already close to failure, a disposal well-positioned unusually close to it, and years of sustained injection. So far, investigators haven't confirmed that specific combination lines up cleanly with this event, which is exactly why the official response has been careful rather than conclusive, which brings us to the fourth explanation. And you might actually smile a little at this one, because the honest answer right now is that nobody fully knows. In my opinion, that might be the most honest of all 4 answers. Within hours of the quake, scientists were already saying exactly that in public. They noted that figuring out the true cause of an event like this takes real time, careful data collection, and detailed modeling. Built-up stress can absolutely reactivate an ancient fault entirely on its own, with zero help needed from anything happening on the surface. In science, hearing the words we don't know yet isn't a cop-out. In this specific case, I genuinely believe it might be the single most accurate sentence in the entire story. If this kind of deep, patient storytelling is exactly what you come here for, tap that subscribe button now. This channel exists to slow down and actually explain the strange stuff happening beneath our feet, not just alarm you and move on. Here's the detail that stopped me cold while researching all of this. Geologists studying the Amarillo-Wichita Uplift have pointed out that it shares a strikingly similar structure with something called the Reelfoot Rift, another ancient failed rift system buried deep underground, but in a completely different part of the country. That rift system sits directly beneath the region where the borders of Missouri, Arkansas, and Tennessee all meet. That is the zone responsible for the legendary New Madrid earthquakes of 1811 and 1812. A sequence so powerful that some accounts from that era describe the Mississippi River appearing to briefly reverse its own direction. Let's be completely clear here. No scientist is suggesting Texas is somehow due for a repeat of anything on that scale. Nobody's predicting a New Madrid-style disaster in the Panhandle. What geologists are pointing out is narrower and honestly more interesting than a simple doomsday warning. Both regions share the same basic geological ingredients: an old failed rift, buried deep, silent for hundreds of millions of years at a stretch. Both systems were built from essentially the same recipe. One of these ancient scars just happens to sit under Texas wheat fields instead of under the Mississippi River Valley. It's worth understanding just how strange and unsettling the New Madrid sequence was for the people who lived through it. This wasn't one single earthquake. It was a series of massive shocks over several months in the dead of winter. It hit in a part of the country that had never given anyone reason to expect anything like it. Survivors described the ground rolling in visible waves, like ocean swells moving through solid earth. Entire sections of riverbank collapsed into the Mississippi. New lakes formed almost overnight where forests had stood the week before. This wasn't folklore exaggerated over time. Much of it was documented by people living in the region as it happened. It was later confirmed by geologists studying the physical changes left behind in the landscape. The New Madrid sequence remains, to this day, among the most powerful earthquake sequences ever recorded in the history of the continental United States. Multiple massive quakes struck that region over just a few months, strong enough to be felt as far away as the East Coast. They were strong enough to ring church bells hundreds of miles distant and to permanently reshape parts of the local landscape. Because that region had almost no population at the time compared to today, the human toll was relatively limited given the scale of the event. If a sequence of that same size struck that same region today, given everything that has been built there since the early 1800s, it would look different. The consequences would look dramatically different and far more severe. What makes the comparison between that region and the Texas Panhandle genuinely interesting to geologists isn't that anyone expects a repeat performance. It's that both areas represent what geologists sometimes call failed rifts, places where hundreds of millions of years ago the North American continent tried to split apart entirely, only to stop partway through for reasons scientists are still working to fully understand. Instead of finishing the job and forming a brand new ocean basin, the crust essentially healed back over, leaving behind a long buried scar, weaker and more fracture-prone than the surrounding rock. It sat there for the rest of geological history, patiently waiting for the right combination of stress to reawaken it, even if only briefly, and on a far smaller scale than what happened in 1811. Understanding that shared geological history doesn't tell us exactly when the next moderate earthquake might strike the Panhandle again, but it does help explain why this region, as quiet as it usually seems, isn't nearly as stable and predictable as most residents have assumed. So what happens next? The United States Geological Survey ran its forecast within hours of the quake, putting the odds of another earthquake of similar size or larger occurring in the coming days at roughly 2%. That's small, but it isn't zero. Their damage modeling came back showing low overall risk, largely because so few people actually live in that specific rural stretch of the Panhandle. This means serious injuries or major economic losses are considered unlikely. That said, low risk doesn't mean zero concern for the people who actually live there. Ranchers and small-town residents across that stretch of the Panhandle spent the following days checking foundations and inspecting old barns. They were swapping stories about exactly where they were when the shaking hit. For many of them, this was the first earthquake they had ever felt in their lives, despite having lived on that same land for decades. That personal experience matters just as much as the scientific data. A statistic that says the risk is low doesn't erase the very real, very human moment of being woken up by a sound that shouldn't exist where you live. But here's why the size of this earthquake matters so much statistically. The Panhandle has now experienced roughly 4 earthquakes of this magnitude, or larger, within about a century, which works out to something happening, historically speaking, somewhere in the range of once every 25 to 30 years. Push that threshold up just slightly to somewhere around magnitude 5.5 or 5.6, and the odds shift dramatically. Scientists estimate an earthquake that size only shows up in this specific region roughly once every 50 to 100 years. Push it further still, up to magnitude 6, and you're talking about something closer to a once-in-3 centuries event. Think of it like a slow-ticking clock hidden inside the Earth, one where nobody knows exactly how the hours are spaced out, but where history gives us a rough sense of the rhythm. Smaller earthquakes tick by more often, bigger ones take longer to arrive, and once in a great while the clock strikes something large enough to make national news. So this magnitude to 5.1 earthquake isn't some bizarre statistical fluke. It looks a lot more like a clock finally striking the hour it was always eventually going to strike. Nobody knew exactly when that hour would arrive, because that's simply how earthquakes work. There's no way to know in advance with real precision. Let's talk a bit more about that second smaller earthquake that struck later the same day. It occurred hundreds of miles south of the main event. That quake, measuring roughly magnitude 3.9, hit a different part of central Texas entirely. It was geologically unrelated to the ancient rift system sitting beneath the Panhandle. It's worth mentioning specifically because it briefly caused some confusion online, with a few people assuming the two events were connected, maybe even aftershocks of one another. They weren't. Texas is simply a large state with multiple separate zones of seismic activity. Some are ancient and largely natural, others more directly tied to modern industrial activity. 2 unrelated earthquakes striking on the same day in completely different regions is really more of a coincidence of timing. This is a question that comes up after almost every notable earthquake in this part of the country, and it deserves a clear, honest answer instead of a quick guess. It's worth explaining a bit more clearly how scientists actually figure out whether an earthquake was triggered by human activity in the first place. Researchers typically look at a combination of factors together. They examine the precise depth of the earthquake. Injection-triggered events tend to cluster at depths closely matching the depth of the wastewater disposal wells themselves. They look at the exact location relative to any active injection sites nearby. They study the timing, checking whether seismic activity in an area increased noticeably after nearby injection operations ramped up. And they compare the specific fault that ruptured against the broader regional stress patterns already mapped out by geologists. When enough of these factors line up together, scientists can build a fairly confident case connecting an earthquake to industrial activity. When they don't line up cleanly, as appears to be the case so far with this specific Panhandle earthquake, the position is different. The honest scientific position is to withhold judgment and keep gathering additional data rather than jumping straight to a conclusion. There's a peer-reviewed study from 2022, published in a respected geology journal, that looks specifically at earthquake activity across the Texas Panhandle. That research, covering 1983 to 2018, found a sustained rise in smaller earthquakes, magnitude 2.5 and above, across that window. It concluded that a majority of those specific smaller events showed signs consistent with being linked to underground wastewater injection. That's genuinely useful context, but it's also worth being careful about what it does and doesn't tell us. That earlier research focused on a large number of smaller, more routine earthquakes accumulated gradually over decades. It wasn't specifically studying an isolated event anywhere near magnitude 5, which is exactly why officials responding to this week's earthquake have been so hesitant to simply extend that same explanation. They won't label this particular event without further investigation. If you're the kind of person who actually wants the full, careful version of a story instead of the panicked headline version, drop a comment. Tell me right now which of the 4 explanations you find most convincing. I read every single one, and I want to know what you think is really happening down there. Let's step back for a moment and think about what all of this actually tells us about the ground we build our lives on. Most people go their whole life assuming the earth beneath their home is simply solid, finished, done changing. But that's not really true anywhere on this planet, and it's certainly not true in the Texas Panhandle. The land there carries scars from processes that started before life on land even existed. A rift that almost split a continent in two. A slow healing that left behind weakness instead of strength. And more recently, a century of human activity, drilling and pumping and extracting, layered right on top of that ancient weakness. None of that means disaster is coming. It means the ground has a memory, and every so often that memory resurfaces. Think about how differently we treat coastlines compared to the middle of a continent. People who live near famous fault lines on the West Coast grow up learning about earthquake drills and retrofitted buildings. People in the middle of Texas rarely think about any of that, because the story they've always been told is that the middle of the country is simply solid ground, safe by default. This earthquake is a quiet correction to that story. It doesn't mean the Panhandle is suddenly as dangerous as a coastal fault zone. It means the line between earthquake country and safe country is a lot blurrier than most maps make it look. Scientists aren't panicking about this earthquake, and you shouldn't either. But it is a genuine reminder that stability is often just a matter of timescale. What feels permanent to us, a human lifetime, 70 or 80 years, is nothing compared to the 500 million years this fault has been sitting there. It has been slowly building and slowly releasing pressure whenever the conditions are right. It's also worth noting how quickly the scientific response actually moved, even while the final answer remained uncertain. Within hours, seismic stations across multiple states had already logged the exact waveform of the quake, giving researchers a precise depth, location, and magnitude almost immediately. Compare that to the earthquakes from the 1930s, pieced together weeks later from letters and newspaper accounts. The speed of modern data collection is genuinely remarkable, even when the underlying cause takes much longer to figure out. Having the what nailed down within minutes, while the why remains open for weeks or months, is actually normal in seismology. The two questions move at very different speeds, and mixing them up is usually where public confusion starts. There's also something worth appreciating in how scientists have handled this event so far. In a media environment that often rewards the most dramatic possible headline, the people actually studying this earthquake have mostly resisted. They've said, again and again, that they need more data. They've openly admitted disagreement between competing theories. They've been honest that some of Texas's earthquake history was recorded with instruments no more advanced than a person's memory. That kind of caution isn't boring. It's actually the most trustworthy thing you can hear from a scientist, because it means nobody's trying to force a tidy answer onto a situation that genuinely doesn't have one yet. So where does that leave us? The ground shook harder in the Texas Panhandle than any seismograph has ever directly recorded there before. That much is settled fact. 4 separate explanations remain technically on the table, and scientists haven't settled on just one yet. And underneath this entire event sits a 500 million-year-old scar carved into the Earth's crust. One that shares its basic structural blueprint with one of the most violent earthquake sequences in American history. What happened in Texas this week wasn't something impossible. If anything, it was something that had been quietly preparing to happen long before the state of Texas even existed. That scar was already down there, waiting, long before the first well was ever drilled. It was there long before the first fence post was ever driven into that soil. It didn't need people to wake it up. It simply needed enough time. We often think of natural disasters as sudden, as things that come out of nowhere. But this one wasn't sudden at all. It was the final brief moment of a process that had been unfolding since long before recorded history. It was moving long before the first human being ever looked up at the sky and wondered what was underneath their feet. Maybe that's the real lesson buried in this story. We build our towns, our roads, our entire sense of normal life on top of a planet that has been quietly rearranging itself for billions of years. It was doing this long before we arrived to give any of it a name. The Texas Panhandle looks calm on the surface, flat fields stretching to the horizon, cattle grazing without a care in the world. But calm on the surface has never meant calm underneath. Somewhere down there, 500 million years of pressure is still working itself out, one quiet century at a time. Until every so often, for just a few seconds, the ground remembers exactly what it once tried to do. If you made it this far, you clearly care about the real story behind the headlines, not just the scary version. So subscribe. Share this with someone who felt that quake or knows someone who did. And tell me in the comments if you'd ever heard of the Wichita Rift or the New Madrid earthquakes before today. I'll be watching for any new updates coming out of the Panhandle. And the moment there's something meaningful to report, I'll bring it straight to you. Until then, remember that the ground under your own feet, wherever you're watching this from, has its own quiet history too. And it's probably a lot older and a lot stranger than you've ever stopped to think about.